In this lecture, we will learn about variables in Python. In simple terms, a variable is like a box or a container that can hold something inside it. Imagine you have a box and you put an apple in it. Later, if you want, you can take the apple out and put an orange in the same box, right? This means you can change what's inside the box anytime you want. In programming, a variable works the same way. It is a placeholder where you can store a value, like a number or a word, and you can also change it later. For example, if you tell the computer to store the number 5 in a variable, the computer will remember it. Later, if you need to change it to 10, the variable lets you update the number easily. Next, we will learn how to declare and initialize a variable in Python. So, declaring a variable means creating a name for storing information, and initializing a variable means giving it a value at the same time. Unlike some other programming languages, Python makes this process very simple because you can do both steps in one line. For example, if you want to store the word apple in a variable, you can write fruit equal code apple code close. Here, fruit is the variable name and apple is the value stored inside of it. Once variable is created, you can easily change its value. For example, you can later write fruit equal orange to update the variable and replace the old value with the new one. Python makes it very easy to create and use variables because you don't need to tell Python what type of data the variable will hold. For example, you don't need to say if the variable will store a number or a word or something else. Python automatically understands what type of data you are storing based on the value you assign. This means you can write a line like fruit equal apple, and Python will know what's storing a word called a string. If later you write fruit equal 10, Python will understand the same variable is now storing a number. This flexibility makes it simple to use variables for all kinds of tasks without worrying about their data types. It allows programmers to quickly store and manage information, making the code easier to write and understand. However, every value in Python still has a data type, such as integers, strings, floats, and more. But Python automatically manages this for you, making programming easier. Don't worry, we will learn these data types in Python in upcoming lectures to understand how different kind of value, like numbers and words, are stored and handled in memory. So just to give you a quick update, and if you're wondering why do we need variable? Well, that's a great question. Well, think of this. Let's say you are using a variable, let's say fruit equal apple, right? Let's say if you don't have that variable, and for that purpose, you're using apple everywhere in the code. And if you want to change that from apple to, let's say, orange, you're gonna have to change every instance of that apple to orange. It's a lot of work. So that's why we have variables where you would change just in that variable, you change apple to orange, and the fruit name of that variable will stay the same throughout your code. So you don't have to change anywhere else in the code. That's the beauty of variable. In this lecture, we will learn about constants in Python. So constants are special values that stay the same throughout the program and do not change, no matter how many times the program runs or how many places the value is used. Okay, so think of a constant as a fixed label or name for a value that never changes. For example, if you want to represent the total hours in a day, you can create a constant like hours in a day. Let's put a underscore in between each word and equal it to 24. right? There are 24 hours in a day, right? So that's why how we define the constant. Now, this ensures the value 24 stays the same throughout your program and can't be even accidentally changed. Now, the main purpose of using constant is clarity. If someone else reads your code, they will instantly know that 24 represents because the constant name explains it. Constant also help prevent mistakes. You only define the value once, so you don't risk typing the wrong number in multiple places. And that is also the main difference between variable and constant. So you're probably wondering that, right? A variable's value can change throughout the program, while a constant value stays the same and cannot be modified. So if hours in a day are 24, we all know it's going to say 24. It cannot be 23, right? Whereas variable, you could put change any number that will be used throughout your code. Okay. Furthermore, in Python, there is no strict rule or feature to make a value unchangeable. But programmers use uppercase letters for constants like pi equal 3.14 to represent pi values that shouldn't be changed. So using constant makes program better because they prevent mistakes. Now, let's take another example. If you accidentally try to change a constant like pi to a different value, it would mean you are going against the rule that constants should stay the same throughout the program. So basically, constants are primarily used for a value that are the right value for it. This also makes debugging easier because you can trust the constant will always hold the same value. Yep. So let's move on and practice this example on PyCharm IDE. In this example, we start by adding a comment to describe that we will define a constant using a pound symbol. Then we define a constant with called pi and assign its value to 3.14, which represents the mathematical constant pi, right? So pi is written in uppercase. It is clear that this value is constant and should not be changed anywhere in the program. Next, add another comment to describe that we will now use this constant. Before doing so, we first create a variable called radius with the value 5. Now calculate the area of circles using the formula pi times r2, where pi multiplies with the square of the radius and stores the result in the area variable. Finally, use the print function to display a message along with the calculated area of the circle. The text inside the double quotes is printed exactly as it is, acting as a label or message. The value of the variable area is displayed immediately after the message, separated by a comma, showing the result of the calculation. So let's run it. Here you can see the result, that is the area of the circle is 78. All right, that's the end of this lecture on the introduction to constant, where we have learned how constants store fixed values that never change and why they are important for making programs reliable and easier to understand. In this lecture, we will learn how to assign multiple values to variables in Python. Python allows assigning values to multiple variables in a single line, simplifying the process and making the code efficient, concise, and of course, easy to read. For example, if you and your friend are holding two different colored balls, for example, right? You have a red ball and your friend has a blue ball. Now, you both want to exchange the balls so that you end up holding the blue ball and your friend ends up holding the red ball. In Python, this swapping happens instantly without needing a third person to hold one of the balls temporarily. This simplicity makes Python swaps quick and efficient, like solving a real life exchange in one smooth action. Okay, when assigning multiple values to variables, each variable is assigned a specific value based on its position. For example, if you write A, comma B, comma C equal 5, comma 10, comma 15, the variable A will get the value 5, right? B will get the value 10, and C will get the value of 15. Now, this is useful for initializing multiple variables at once. Now, let's practice this example in PyCharm IDE. First, let's use the traditional method to create three variables, one by one on separate lines. For example, create a variable A and assign it the value of 5, and then B and set its value to 10, and finally C and assign it the value of 15. Print them to display their content with messages like value of A is 5, value of B is 10, and value of C is 15. Run it to see the result. Okay, now let's combine these variables into one single line. For this, write A, comma B, comma C equal. Now let's say this time we'll use 50, comma 100, comma 150. Of course, here A gets 50, B gets 100, and C gets what? 150. Now let's print the variable using the same method as earlier and run the program. The output displays the value correctly, confirming this approach works perfectly. Beautiful. This saves time and reduces errors in repetitive code. Now, next, let's learn how to swap values between these variables. In Python, you can swap two variables without a temporary variable. For example, a comma b equal b comma a will exchange their values. Like the value of a moves to b and the value of b moves to a. Let's print these values and run the code to confirm the swap works as expected. This feature is simpler and more elegant compared to other programming languages. However, please make sure the number of variables on the left matches the number of values on the right-hand side. Otherwise, Python will throw an error. For example, p comma q equal 1 comma 2 comma 3 gives too many values to unpack. Error. While p comma q comma r equal 1 comma 2 gives an error that reads not enough value to unpack. All right, let's comment out such lines before proceeding. So this method also supports assigning the same value to multiple variables. For example, x equal y equals z equals 0. Assign z to all these variables. All right, let's print and run the code to verify they all share the same value. Furthermore, you can also perform operations while assigning values. And for example, writing x comma y equal 5 plus 3 comma 10 times 2. Here, first, it calculates the result 8 and 20 before assigning them to x and y. Let's print the variable to see x as 8 and y as 20. So this allows efficient calculation and assignments in a single line. So that's the end of this lecture on assigning multiple values to variables. I want you to practice these techniques to enhance your coding skills. And I will see you in the next lecture. In this lecture, we will learn some basic mathematical operations. So we already used the plus sign to combine strings or as a mathematical operator to add two integers, basically two numbers. Let's move on to the next one, which is subtraction. The minus sign is used for subtraction, as we all know, right? So, for example, 12 minus 5 equals what? 7. We will use the print function because the calculation happens first, and the print function simply displays the result, as you can see here. But when you get to multiplication, it's a little bit different. Instead of using the cross symbol, we use the asterisk sign. So you can write something like 4 times 7, and many times this asterisk is also referred to as star. Now, the final basic operator is division, and that's done using the forward slash. For example, 16 slash 4. When this is printed, it will give you 4. One thing to notice here is that whenever you divide numbers, you always end up with a floating point number. Even though 16 divides evenly into 4, you'll still get 4.0. In fact, if you perform a type check on this division, you will see that it prints a float instead of an integer. A float is a data type used to represent numbers and decimal points. Don't worry, we'll discuss all data types in the upcoming lectures. This is just the default Python behavior and is something called the typecasting because Python is converting the result into floating point number. Sometimes you might not want this. In such cases, there's another Python division operator worth knowing about. It's done using two forward slashes. When you run it, you will see that the result is an integer. If you perform a type check, you will confirm it comes out as an integer instead of a float. However, you need to be very careful with this second type of division operator because what it's doing behind the scene is performing the division first and then simply removing all the decimal places. For example, 18 slash 6 divides evenly into 3, but if we divide 17 by 6, the result would be 2.833 and so on. If we use the double forward slash like 17 slash slash 6, it will give 2, effectively cutting off all the decimal places. This behavior, of course, can be risky if you're working with scientific numbers, but can be useful when you need a result with no decimal. All right, so let's move on to discuss the double asterisk, which gives you access to exponents or powers. For example, if you want to calculate 3 to the power of 4, you will write 3 asterisk asterisk 4. This means 3 times 3 times 3 times 3, which equals to what? 81. So if you change it to 3 asterisk asterisk 5, meaning 3 to the power of 5, then basically it means 3 times 3 times 3 times 3 times 3, which equals to 243. Having exponentiation built into the language is one of the reasons Python is popular with the data scientists and mathematicians. It's optimized for working with numbers. One thing to be careful about when performing mathematical operation is when you have more than one operation on the same line of code. Python follows a certain order of procedure, meaning some operations like division or multiplication take priority over others, like addition or subtractions. The rule you might remember from high school is called PAMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. The operations are executed in this order as we have that PAMDAS. The first thing is parentheses, second is exponents, then comes multiplication and division, both treated equally in priority. Finally, addition and subtraction treated equally in priority. It's important to note that multiplication does not necessarily happen before division. They are of equal importance. When both appear in a calculation, Python processes them from left to right. Let me give you an example to clarify. Let's say we have 4 times 6 plus 8 divided by 4 minus 9. If you execute this entire line of code and print it to the console, you will get a number, but the order of execution matters. Let's break it down using PAMDAS method. I feel like as if I am teaching you maths, but I'm sure it doesn't hurt to refresh our memory. First, 4 times 6 is executed. which becomes 24. And because m is for the multiplication, next 8 divided by 4 is executed, which becomes 2. Then 24 plus 2 is executed, which becomes 26. Finally, 26 minus 9 is executed, resulting in 17. So the output of this line is 17. Furthermore, let's see what happens when we add parentheses around 6 plus 8. So this operation will be prioritized differently due to parentheses. So 6 plus 8 evaluated first and became 14. Then 4 times 14 is evaluated, resulting in 56. Next, 56 divided by 4 is evaluated, giving 14. And then finally, 14 minus 9 is evaluated, resulting in 5. So by isolating certain calculations using parentheses, you can prioritize them and control the order of execution. That's the end of this lecture on how to perform a basic mathematical operation. Now it's your turn to practice, try out different operation and experiment with various numbers to see the result. And I'll see you in the next lecture. In this lecture, we will learn about global and local variables. In Python, local and global variables are used to store data or information that can be accessed and modified while a program runs. The key difference between the two is where these variables are created and where they can be used. Let's first understand what a local variable is. It is a variable that is defined inside a function or a block of code. Don't worry, we'll learn about functions in detail in the upcoming lectures. So, local variables are temporary and can only be accessed within that specific function or block. Once the function finishes running, the local variable is deleted and its value is no longer available or used. For example, think about cooking a pasta. While boiling the pasta, you use a timer to check the cooking time, right? Most of the people do. The timer is only used for this specific task and has no role or value after the pasta is cooked and ready. Similarly, a local variable in Python is like a timer. It is created and used only for that specific task inside a function and is discarded once the task is done. All right, for example, if you set the timer for 10 minutes, the timer doesn't affect anything else in the kitchen. In Python, a local variable works the same way. It exists temporarily in a specific area function and does not interfere with other parts of the program. If you try to use this variable outside the function, you'll get an error because the variable is not recognized outside its local scope. All right, let's talk about global variable. On the other hand, a global variable is defined outside of all functions, usually at the top of a program. This type of variable is accessible and modifiable from any part of the program, including inside functions. However, to modify a global variable inside a function, you need to declare it as global using the global keyword. Yep. For example, think about running a household and there is a shared calendar hanging on the wall or on your fridge. This calendar is visible to everyone in the house, and all family members can check or update it. If someone writes, let's say, grocery shopping on Saturday, everyone in the family knows about it because the calendar is shared and accessible to everyone. In Python, a global variable is just like that shared calendar. Yep. It is defined outside any specific function, making it accessible to all parts of the program. For example, if you define a global variable and let's call it weekend plan with underscore in these two words and equal sign and then relax at home. And of course, we put that in double quotes. All the function in your program can read or modify this variable if needed. However, since everyone can update, changes to the global variable might affect all functions, so you need to use it carefully. So until now, we have used global variables in our examples because we haven't learned about functions yet. Since global variables work throughout a program, they have been sufficient so far. All right, once we learn functions, we'll start using local variables as well. So I'll see you in the next lecture. Hey, boys and girls. In this lecture, we will learn about built-in data types in Python. So a data type in Python tells the computer what kind of information a variable will store. It's like a label that says this is a number or this is text. Using the right data type helps the computer to understand how to handle the information. For example, if you use a bottle to hold water and a box to store toys, you wouldn't put water in a box because it wouldn't work well, right? Similarly, in Python, a data type makes sure the information fits and can be used properly, like storing numbers for math or text for writing. So Python has three basic built-in data types, such as integer for the whole numbers, float for decimal numbers, and string for text. Here I want to tell you again that you don't need to write the data type before a variable. Python is smart. It figures out the data type for you based on the value you assign. That's why we don't need to specify these data types when creating a variable. If we do, Python will give an error. However, the purpose of learning data types in Python helps us understand how numbers, text, or collections are stored and used in specific ways, such as using integers for calculations or string for text handling. In Python, there is no separate character data type to handle single characters, as there is in some other programming language like C Sharp or Java. Python uses the string, which is in short str, data type to handle both single characters and sequence of characters. A single character in Python is simply a string of length 1. Let's see how much these data types have capacity or memory to store value. In Python, integer type has no fixed size limit. You can store numbers as small as like -2 billion or as big as you can imagine. Your computer's memory is the only limit. Now, the float data type can handle numbers as small as 1.7 times 10 to the power of -308, which means 307 zeros after the decimal point, and as large as 1.7 times 10 to the power of 308, which means a number starting with 17 followed by 307 zeros. And string can store any sequence of characters, from a single letter to an entire book. The amount you can store depends on your computer's memory, allowing you to handle massive pieces of text effortlessly. That's why Python is gaining popularity every day. It offers incredible flexibility and ease of use. So, as we move further in this course, we will explore even more amazing features that make Python so powerful. All right, I'll see you in the next lecture. In this lecture, we will learn about type conversion and casting in Python. Type conversion and casting are processes that allow us to change the data type of a value from one type to another. Type conversion and type casting are related but different concepts. The type conversion happens automatically when Python needs to combine different data types in an operation, like adding an integer to a float. The type conversion is also known as implicit type conversion. As you already know, Python is a dynamically typed language, which means you don't need to specify the data type of a variable when declaring it. We already covered that many times, right? I'm sure you have a good understanding on that. However, there are times when you need to convert one data type to another, either for compatibility or specific operations. For this, you need typecasting, which is used by the developer to manually change the data type. It is done using functions like integer or int and parentheses, also float parentheses or string parentheses. Typecasting is also known as explicit type conversion. And I said previously, type conversion is known as implicit. This one casting is explicit. So keep that difference in your mind. Okay, so the main purpose of type conversion and type casting is to make a data compatible for operations or tasks. For example, if you are shopping online and the price of an item is stored as in string, like let's say 50. If you want to calculate the total price after buying three items, you can't multiply a string directly by a number. You would use a typecasting to convert the string 50 into an integer 50 so you can calculate the total. All right, let's move on to do some practice. Here we create a variable age and assign it to the value, let's say 20, which represents an integer, right? And then create another variable height and assign it the value, let's say 5.5, which represents a float. And as you know, float, we're using it because it is a decimal value. Okay, when we add these two variables together, like age plus height, Python automatically performs implicit type conversion. Since one of the values height is a float, Python converts the integer value age into a float to ensure the calculation is accurate and consistent. This process allows the addition of different data types without errors. The result of the operation is 25.5, which is a float. So it added 20 for the age and 5.5 for the height. Okay, let's create a simple example to understand explicit type conversion now. For this, let's first ask the user to enter the number of apples they have. All right. The input from the user is stored in the variable, and we call the variable user underscore input, which by default is a string in Python. To perform mathematical operation on it, we need to explicitly convert this string into an integer. Yep. We do this using the int integer function to perform explicit type conversion and store the converted value in the variable, and we call that variable apples. Next, we calculate how many more apples are needed to reach a total of 10. This is done by subtracting the number of apples entered by the users apples from 10, and the result is stored in the variable apples underscore needed. Again, just a variable we created. Finally, we display the result to the user, showing how many more apples they need. All right, let's run the program. All right, the program is asking enter the value 5 and press enter. You will see the result. Right here, you see you need 5 more apples to have 10. So this explicit type conversion ensures that we can perform the subtraction operation smoothly without any errors, as the input is now in the correct integer format. Yep. In this lecture, we will create a real life example, which is weekly meal planner. All right, all my healthy learners, let's do something creative. This program helps you plan your weekly meals and calculate water requirements. It displays a detailed meal plan for each day, covering breakfast, lunch, and dinner, while also summarizing the total meals and water needed for the week. All right, let's get started. First, open your PyCharm IDE. Okay, let's add a comment. At the top of the file, constants, and then define water liters per day. And of course, separate each word with underscore. And this is a variable, and define that variable, set the variable equal to 2 as a constant to emphasize that everyone should aim to drink this amount daily for good health. Yep. Now let's move ahead and set up predefined meal options for each day of the week. All right, for that, we will create 9 different variables: two for daily breakfast and lunch options, and 7 for unique dinners, one for each day of the week. All right, a lot of good stuff. Okay, for example, the breakfast variable is set to cereal and milk, which will be the same every day, and lunch is set to chicken salad for the whole week. All right, I hope you like chicken salad. Okay, for dinner, each day we get a unique meal like grilled chicken on Monday, pasta on Tuesday, tacos on Wednesday, and so on. I'm sure you got the idea, right? These predefined meals help the program create a consistent and varied weekly meal plan automatically, making it easy to organize and update. Next, we will display the weekly meal plan in a clear and organized table format. To make the meal plan clear and easy to follow, we start by creating a header. This includes a title and call it Weekly Meal Planner, followed by label column headers for the day, breakfast, lunch, and dinner. So this horizontal line is printed to separate the headers from the actual data. For each day of the week, we display the day's name along with the meals planned for the day. Breakfast is the same every day, so it will be cereal and milk. And I hope you don't get bored with that. Okay. And lunch is also the same every day, which is chicken salad. Of course, if you don't like chicken salad every day, then you could change it. But of course, you could try that once we go through this practical example. All right, so as you already know, dinner changes daily with different meal assigned to each day. All right, this way the meal plan includes variety of dinners while keeping breakfast and lunch consistent. All right, let's move on and calculate the total number of meals planned for the entire week. So, as you calculate, there are 7 days in a week, as you know, and we plan for 3 meals each day, and breakfast, lunch, and dinner. And the formula will be 7 times 3 is used to get the total. This multiplication gives us the result of what? 21, which means that the program has planned a total of 21 meals for the week. After that, we calculate the total amount of water needed for the week based on the daily requirement. Here, the constant water liters per day is set to 2. Now, by multiplying this daily requirement by 7, the number of days in a week, the program will calculate the total water intake needed for the entire week. This results in 2 times 7 equals 14, meaning a total of 14 liters of water is required for the week to stay properly hydrated. Finally, we will provide a summary of the weekly meal plan and water requirements. It begins by printing a blank line for which we have to put in /n to separate the summary section for better readability, followed by the heading summary. The next 2 lines display the total number of meals planned and the total amount of water needed for the week. We use the string str parentheses function to convert the numeric value of weekly underscore water into a string so it can be combined with the text. All right, now let's run the program. Here you can see the output that displays a weekly meal planner with clear table format showing breakfast, lunch, and dinner for each day. Beautiful. Finally, the summary highlights that a total of 21 meals are planned for the week, with 14 liters of water required for the week to stay hydrated. This organized output ensures easy understanding and tracking of meals and water intake. All right, folks, try customizing the meal of your choice options or experimenting with different daily water requirements to see how the program adjusts and calculates the total for your weekly plan. All right, stay healthy, and I'll see you in the next lecture. In this lecture, we will learn about strings in Python, which, by the way, we have covered briefly in the previous lectures. A string is a sequence of characters. Characters can be letters, numbers, spaces, or symbols. Strings are one of the most important data types in Python because their purpose is to store and manipulate text such as words, sentences, or symbols. So, in short, they are used for handling text. When you write text in Python, you usually enclose it in either single quotes, double quotes, or triple quotes. For example, hello in double quote or hello in single quote are both valid strings in Python. Triple quotes are often used for multi-line strings, allowing you to write text that are in several lines. Strings in Python are immutable, which means once you create a string, you cannot change its individual characters directly. For example, if you have a string like apple, you cannot change the first character A to B. However, you can create a new string by combining parts of the original string with other text. Python makes it easy to manipulate and create new strings through various built-in functions and operations. Python provides many ways to work with strings. For example, you can use the plus operator to combine two strings into one. This is called concatenation, right? In Python, you can use the multiplication operator, which is represented as asterisk, to repeat a string multiple times. This is a unique feature in Python that allows you to create repeated patterns or text quickly. For example, when you take a string like hi and multiply it by a number, for example 3, Python creates a new string by repeating the original string. Okay, so hi times 3 means that Python will repeat the word hi 3 times in a row. The result will be hi, hi, hi. That's funny. Okay, strings also support many built-in methods for performing various operations. You can use dot lower parentheses to convert a string to lowercase or dot upper parentheses to convert it to uppercase. For example, Python dot lower parentheses returns Python with all small letters, and Python with uppercase P at the beginning dot upper parentheses return to Python all capital letters. Similarly, the dot strip parentheses method removes any extra spaces from the beginning and end of the string. Furthermore, if you have a string with extra spaces like let's say space hello and space, you can use dot strip method or sorry function to remove them, having hello without spaces. And if you want to check a string that starts or ends with specific letters, you can use dot starts with parentheses function or a dot ends with parentheses. For example, Python with double quotes dot start with opening parentheses opening double quote pi closing double quote with closing parentheses will check if Python starts with pi and returns true. These methods are helpful for cleaning and verifying text in Python. In this lecture, we will learn about string slicing techniques in Python. So, string slicing is used to get a part of a string by choosing specific positions without changing the original string. For example, if you have an email address, let's say like imran.afzal at example.com, and you want to extract the first part, which is, let's say, the username, that could be imran.afzal. Now, this can be done with string slicing, and it can be done very efficiently. Strings in Python are sequences of characters, and each character has a position or index. These indices start from 0 for the first character and go up to minus 1, where n is the length of the string. You can also use negative indices, which start from minus 1 for the last character and move backward. Here, the word indices is an important concept. Without understanding it, we cannot slice a string. So let's first understand it. Yep. Okay. So the word indices means more than one index. For example, in a string, an index shows the position of one character, like 0 for the first character, right? If we talk about many positions, we call them indices. For example, if we have a string Python, the positive indices start counting from the beginning. Like index 0 gives the first character P, and index 1 gives the second character Y. On the other hand, negative indices start counting from the end, and that would be like index minus 1 gives the last character N, and index minus 2 gives the second to the last character, which is O. Yep. So positive indices move forward from 0, while negative indices move backward starting from minus 1. The basic syntax for slicing a string is string and bracket start colon end colon step, and then close it with the bracket. The start is the index where the slice begins, and end is the index where the slice ends. But it is not included in the result, and the step defines the interval between characters in the slice. All these parts are optional. For example, if you don't specify the start, the slice will begin from the very first character of the string. If you don't specify the end, it will go up to the last character. If you don't specify the step, it will automatically take every character one by one. Let's take an example to understand this better. Suppose we have a string text, that is always our favorite words. Let's hello world. If you want to extract the word hello, you can use a slicing as text bracket 0 colon 5 and close it with a bracket. Here the start is 0 and the end is 5. Yep. Python indices the characters from index 0 to 4, excluding the character at the index 5. So the result is hello. If you want to extract the word world now, then you can write text with starting with bracket 7 colon 12 and close the bracket. Again, it includes characters from index 7 to 11 but not 12. Slicing also works with negative indices. If you want to extract world using negative indices, you can write text bracket -6 colon -1 and close the bracket. So as you know, negative indexing starts from the right, so -1 refers to the last character, which what we have exclamation, right? And -2 refers to the D, and so on. So by specifying -6 colon -1, Python extracts the character starting from the sixth position from the end to the position before the last. You can also skip characters using the step parameter. For example, text 0 colon 12 colon 2 will return HLO space OL because it selects every second character from the index 0 to 11. If you use a negative step like text colon colon minus 1, it will reverse the string. This is because the slice starts from the end and moves backward. Reversing strings with the slicing is a common Python trick and very efficient. Another useful feature of string slicing is its ability to handle default values. If you want to slice from the beginning of the string to a certain index, you can omit the start value. For example, text colon 5, of course, will always surrounded with brackets, will give you the word hello. Similarly, to slice from a certain index to the end of the string, you can omit the end value like text 7 colon, which gives world with, of course, exclamation at the end. If you want the string, or sorry, the entire string, you can use text and then just the colon inside the bracket, which essentially copies the string. String slicing is a safe operation because it never throws an error if the indices are out of bounds. For example, if you try text 0 colon 50, Python will simply return the characters up to the end of the string, even though index 50 does not exist. All right, that's it about string slicing. Now it's your turn to practice it, and I'll see you in the next lecture. It's time to create a practical and real life example, and that is personalized email generator. Okay, this program will help you to create a personalized email. The user will enter the email name only, and the program will convert it into a proper full name, add at example.com to create the full email address and generate a simple email message for the user. By the way, I am just picking this example.com, just an example for this video. All right, let's get started. First, open your PyCharm IDE and create a new Python file. Name the file email generator so it clearly reflects the purpose of the program. So, first we ask the user to input an email name and store it in the email underscore name variable. It's just a variable that we picked. This input will typically include a first name and a last name, separated by either a period or an underscore. So, to clean this input, we will convert it into a neatly formatted full name with the first letter of each name capitalized. For example, if the input is, let's say, Imran.Afzal, the output for the name will be simply Imran Afzal. Of course, we'll have a space in the middle. Similarly, an input like John underscore Wick will be formatted as John Wick. For this, we use the replace function to find dots, which is dot in parentheses and underscore in parentheses in the email underscore name and replace them with spaces. The formatted full name is then stored in a variable and we'll call it cleaned underscore name. After that, we will split the cleaned underscore name variable into a first name and a last name. For this, let's start first find the position of the first space in the variable cleaned name and take everything before it as the first underscore name. After that, we start from just after the first space and take the rest of the string as the last name. This helps separate the cleaned name into two parts, first and last names. After that, we will be capitalizing the first and last names initials and combine them into a single string. All right, for this, we will take the first letter of the first underscore name, which is in our case is the variable, and converted it to uppercase while keeping the rest of the letters the same as lowercase. Then do the same for the second variable, which is last underscore name, capitalizing the first letter and keeping the rest as is. Then a space is added between the first and last names to join them together. All right. In our case, if the first underscore name is Imran and the last underscore name variable is Afzal, this line will turn them into Imran with uppercase I, space Afzal with uppercase A to ensure the name is clean, professional, and properly formatted. Okay, next we will generate a complete email address by appending at example.com. It's just a domain that I picked, it doesn't exist, to the input provided by the user. After generating the formatted name and email address, we will then prepare a personalized email template using Python's f-string formatting. I'm sure you remember that, right? The template includes a salutation, like dear, and then followed by the user's formatted name and a message stating their complete email address. It ends with a polite closing, and let's make that closing as best regards. By embedding variable directly, the program dynamically personalizes the email, ensuring it is unique and professional. Then we will customize the email by replacing the placeholder name in curly braces in the email template with the actual name stored in formatted underscore name variable. The replace function looks for name, which is in curly braces in the template, and substitutes it with the recipient's full name. For example, if the formatted underscore name is Imran Afzal, the line will update the template to include Dear Imran Afzal instead of just Dear and name in parentheses. This makes the email more personal for the recipient. Finally, we will display the personalized email by printing the personalized underscore email variable. So, after all the placeholders in email template have been placed with the recipient's details, it showed the completed email message on the screen. Sweet. Okay, it ensures you can see the final output with the recipient's full name and email address included. All right, now it's time to run the program. The program prompts a message asking the user to enter the email name. Let's type, for example, imran.afzal and press enter. Now you can see the output that shows the email name into a proper full name, like Imran space Afzal, by capitalizing the first letters. It also generates the full email address by adding the at example.com to the entered name, resulting in what? Imran.afzal at example.com. By the way, guys, this is not my real email, so don't send me any email to this address. It's just a domain I picked for this lecture. All right, finally, it combines the detailed into personalized email message, addressing the recipient by name and sharing their complete email address. The message ends with best regards to maintain a professional tone. Now it's your turn to take some time to practice this program, and I'll see you in the next lecture. Hey everyone! We are very excited to introduce you to some amazing AI tools that will make your Python learning journey easier, faster, and way more fun. So, the main reason we are adding this section here is to show how powerful AI tools are changing the way people learn and solve problems, specifically in programming. Some of the most popular AI tools are like ChatGPT, created by OpenAI, which can hold a natural conversation and assist with learning and problem solving. I'm sure you know by now. Then we have Gemini AI, which is created by Google, known for its advanced reasoning and ability to generate detailed responses. And also there is Bing AI Chat created by Microsoft as well, which combines search engine power with AI to provide quick and accurate answer. All right, let's focus on ChatGPT and see how it works or how it makes a Python's developer's life easier and more productive. All right, ChatGPT acts like a coding partner specifically for Python tasks, whether it's creating functions, generating scripts, or writing complete Python programs. It helps with debugging Python code by identifying errors, explaining why they happen, and providing solutions. ChatGPT also optimizes Python code by suggesting cleaner, faster approaches to improve performance. Furthermore, it assists in writing boilerplate Python code, like setting up basic templates, handling repetitive tasks, or generating commonly used code structure. So, by saving time and simplifying complex Python tasks, ChatGPT helps developer focus more on building efficient and high quality Python projects. Many big companies are already using AI tools like ChatGPT to improve their products and services in programming. Microsoft has integrated ChatGPT into tools like GitHub Copilot, which helps developers write code faster. Google is developing its own AI tools like Gemini AI, while Amazon is using AI to improve customer experiences and automate tasks. It's not just only for large companies, but smaller businesses also use ChatGPT, especially for startups and freelancers, to save time and bring new ideas to life. We can share something even more exciting with you. Did you know ChatGPT was built using Python? Yes, it is true. This shows how powerful and useful Python is for creating smart tools. It proves that Python isn't just easy to learn, it's also a key language shaping today's technology. That's why we are here to help you build a brighter future for mastering powerful tools like Python and learning how to make coding simpler with ChatGPT. So you could use ChatGPT to write codes for Python. So it's like chicken and the egg. So did chicken come first or the egg came first? So Python is the tool, the coding was used to write ChatGPT, and now ChatGPT is so powerful that it's generating the code to write Python programs. Isn't that beautiful? All right. So that's it. That's why that was the main reason I wanted to include this ChatGPT section in this course because I want you to be prepared and use ChatGPT to improve your code and troubleshoot them, which we will cover in the upcoming lectures. In this lecture, we will learn how to generate Python programs or code using ChatGPT. Let's dive into a fun example to see how easily you can create a program, of course, using ChatGPT. Imagine you are running a cafe shop and wanting a program to calculate coffee prices with personalized discounts. All you need to do is ask ChatGPT something like this. Write a Python program in Python for a cafe shop to calculate coffee prices based on the rules. And the rules are customers under 18 get 20% discount. Those between 18 and 60 enjoy a 10% discount. And those are over 60 receive a generous 50% discount. Furthermore, if a customer has a loyalty card, they will get an extra 5% discount on top of that. All right, that's it. That information is enough. Now let's go ahead and hit enter and let's see what ChatGPT tells us. All right, here it goes. ChatGPT is now generating the code for you. Within moments, you will have a neat Python program that asks for a customer's age and whether they have a loyalty card, calculates the discount, and gives the final price. You can also run this code directly in ChatGPT, but when we try to run it, it gives us an error. Why? Hmm. Because ChatGPT doesn't support programs that require user input. Yep, it can only show outputs for programs without input prompts. So let's copy this code and run it on our own compiler to see it in action. All right, let's open PyCharm and create a new Python file and let's name it Cafe Shop. Paste the copied code into the file and then hit enter or run button. Now, the program starts by asking you to enter your age. All right, let's type 61 and press enter. Next, it prompts again and asks if the user has a loyalty card. Let's type yes and press enter. The program processes the information, calculates your total discount, and displays the final price for the coffee, which is $13.50. So you can see how simple, quick, and efficient it is to create Python program using ChatGPT. That's so sweet. So this is how simple it is to create and run a program with ChatGPT. I want you to try them, start practicing, and bring your own ideas to life. Ask ChatGPT to generate some code for you, copy those codes, and paste it in your PyCharm and see how it works. All right, let's create a practical and real life example, and that is restaurant menu selector. This program will help you to select an item from the restaurant menu and calculate your total bill based on your order. After choosing an item and entering the quantity, the program will calculate the total amount to be paid. If a valid item is selected, it will display the order summary with the total bill. However, if an invalid option is selected, it will notify you to choose a valid item from the menu. All right, fair enough? Okay, so let's get started. For this, open your PyCharm IDE and create a new Python file. Name the file restaurant menu selector so it is easy to understand what the program does. At the top of the file, we add a comment that explains this program. All right, let's start with step one, where we will print a welcome message. For this, use the print function to display a message saying, let's say, welcome to the restaurant menu selector. This makes the program friendly and engaging for the user, right? Okay, move on to step two, where we will display the menu items so the user can choose what to order. We will use several print functions to show the items and their prices. And let's make up the menu for that. For example, we write today's menu, which starts with the number one, pizza, costing, let's say, $12. Then we have a burger or sandwich at a number two with a price of, let's say, $8. After that, we have pasta at number three, priced at $10. And finally, at number four, we have salad costing $7. This gives the user a clear list of available options. Now it's time to move on to step three, where we will need to ask the user to make a choice from the menu. For this, we use the input function to take the user's menu choice. Since the menu options are numbers, like 1 for pizza, 2 for burger, that's why we display a message for the user to enter the number of the item you want to order. Then convert the input into an integer using the int function and save it in the choice variable. It's a lot easier to have number selected instead of typing the option name. Okay, after getting the user's choice, we also need to ask how many items they want to order, which is the quantity, right? For this, we use the again input function and display a message for the user to enter the number of quantity, all right? For example, if the user wants two pizzas, they will enter what? Two. Then we convert this input to an integer as well and save it in quantity variable. Then moving on to step four, where we will initialize two important variables, item and price. The item variable is set as an empty string because at the start, we don't know what the user will choose from the menu. And the price variable is set to 0 initially because no item has been chosen yet. Then moving on to step 5, where we will find out what item the user selected and what price it's on. For this, we will use the ladder statements and compare the user's choice with the menu option. For the user enter 1, it means they want pizza. So we set the item name to pizza and the price to 12. If they enter 2, it means they want burger, so we set the item name to burger and the price to 8. Similarly, if they enter 3, and that is for pasta, a 4 for salad, and so on. You got the idea, right? If the user enters any number that is not on the menu, we set the item to invalid and the price to 0. So let's say if they enter 0 or enter, like, let's say 7, that's not in the menu. All right, let's move on to step 6. Once we have the item name and price, now it's time to calculate the total bill by multiplying the price of the item by the quantity. For example, if the user orders 2 pizzas, we multiply 12 by 2 to get the total price of 24. And store this value in a variable, and let's call it total price. Moving on to step 7, where we will check if the user selected a valid or invalid menu item. If the item is not invalid, we will display the order summary to the user. For this, we use the print function to show the order summary. Below this, we display the item name, the quantity, and the total bill. For example, if the user orders 2 burgers, the program will displays it like this. Item name is burger, quantity is 2, and total bill is 16. By the way, nowadays you could relate this example to Uber Eats, where you could actually go to the Uber Eats menu and then pick what you want to order, the quantity, and it will tell you the total bill. Is that application is written like just like this with the latter statement. All right, now you have the real life examples in your head to compare what we are doing. All right, moving on. If the item is invalid, we will display an error message saying invalid choice. Please select a valid item from the menu. This helps guide the user to choose the correct option. Finally, let's test this program by running it. The first thing you will see is a welcome message followed by the menu. Then the program will ask you to enter the item number. Let's type, for example, 1 for pizza and press enter. Then we'll ask you for quantity. Let's type 2 and press enter. Now the program will calculate the total price as 24 and display the order summary. But if you enter a number that is not on the menu, let's say 5, the program will show an error message saying invalid choice. All right, now I want you to go ahead and try out different options. Run the program and enter different value and see how it works. And I'll see you in the next lecture. Exercise movie ticket price checker. Let's create a practical example. A program to check movie ticket prices based on age and loyalty card discounts. The program calculates the final price by multiplying applicable discounts and displays the ticket details. So the first step is to set base ticket price. Assume the base price of a movie ticket is $500, which is very high. Wow. Okay. Stored in a variable called base underscore price. This will be used to calculate the discounted ticket price. The second step is to take user input. And in this program, ask the user for their age and whether they have a loyalty card. The inputs are stored in a variable age and loyalty underscore card respectively. To handle varied input formats, the loyalty card response is converted to lowercase. All right, moving on to step 3, which is to validate inputs and apply age-based discount. The program ensures the loyalty card input is valid, which is yes or no, and prompts the user for correction if not. For valid inputs, nested if-else statements calculate discounts, which is 50% for users below 18 years, 20% for users age 18 to 60, 30% for users above 60. Okay, then moving on to step 4, which is to apply loyalty card discount. If the user has a loyalty card, an additional 5% discount is applied on top of the age-based discount. All right, then moving on to step 5, which is to calculate final ticket price. The final ticket price is calculated as base underscore price, which is a variable, times 1 minus a discount, and put that within parentheses. And stored it in final underscore price variable. For example, a 65-year-old with a loyalty card gets a total 35% discount, making their ticket $325. All right, then in step 6, display ticket details. The program prints the base ticket price, discount percentage, and final price formatted to 2 decimal places. Then testing the program. Now run the program to verify different scenarios. For example, entering age 65 and loyalty card responds to yes, applies a 35% discount, calculating a final ticket price of 325. Try it with different inputs to see how the discounts work. And I will see you in the next section. Hey folks, in this lecture we will learn about loop control statements in Python. Loop control statements are special instructions that allow you to manage the flow of loops. As you know, loops are used to repeat a block of code multiple times, but there are situations where you may want to modify the loop's behavior. For example, you might need to stop the loop early, skip certain iteration, or exit nested loops. This is where loop control statements come into action and make your program more flexible and efficient. So the main purpose of loop control statement is to give you control over the repetition process. There are three main types of loop control statement in Python: break, continue, and pass. The break statement stops the loop completely and makes the program move on or move to the code after the loop. It's used when you want to exit the loop early. The continue statement skips the current loop step and moves to the next step one. It's helpful when you want to ignore some specific cases, but you keep the loop running. The pass statement does nothing. It is simply a placeholder. It's useful when you plan to write a code later, but want the program to run without errors in the meantime. Let's understand these terms in a real life example. For example, you are handing out candies to children at a party, and you are looking for a child who hasn't received any candy yet. You go through the line one by one. You find a child who already has a candy. You skip them and move on to the next child. This is like using a continue statement. If you find the first child who hasn't received candy, you give them the candy and stop looking further. This is like using a break statement because you have found the child you were looking for. So there's no need to check the rest. If you see a child who doesn't want candy, you simply smile and move on without doing anything. This is like a pass statement. These small actions help you manage the process efficiently, just like loop control statement makes loops work effectively in Python. Let's practice a simple example on PyCharm IDE. So we are creating a program to check the number from 1 to 10. For each number, we'll check if the number is 5. If it is, we will end the loop and indicate the number is found. If the number is even, we will skip it and move on. If the number is odd, we will simply move on without doing anything. For this, we use a for loop and create a variable called number, which represents the current value in the sequence generated by the range function starting from 1 to 11. Inside the loop, the first thing we check is whether the number is equal to 5. If it is, we print a message saying, "Found the number 5," stopping the loop. Then we use the break statement to stop the loop completely because we don't need to check any more numbers once we find 5. Next, if the number is not 5, we check if it is even. We do this by checking if the number is divisible by 2. If it is even, we print a message, "This number is even," skipping it. Then we use the continue statement to skip the rest of the loop for the number and move to the next one. If the number is neither 5 nor even, it must be odd. For odd numbers, we print a message, this number is odd, doing nothing special. Then we use the pass statement, which does nothing and simply acts as a placeholder, allowing the loop to continue normally. All right, let's run the program. The loop processes each number step by step. For odd numbers like 1 and 3, it uses the pass statement to do nothing special and prints a message saying they are odd. For even numbers like 2 and 4, it uses the continue statement to skip further processing and prints that they are even. When the loop reaches 5, it uses the break statement to stop the loop, prints found the number 5, stopping the loop and ends the program. So this is how break, continue, and pass statement work together to control the flow of the loop. And I'll see you in the next lecture. Hey folks, let's create a practical and real life example, and that is guest check-in system. This program will help you manage the check-in process for guests. After entering the maximum number of guests allowed, the program will allow you to input guest details, including their name, age, and reservation status. If the input is valid, the program will process the check-in and notify you of a successful entry or provide reasons for denial. However, if invalid inputs are provided for age or reservation status, the program will notify you to re-enter the correct information. Once the maximum number of guests is reached, the program will end with a message confirming that check-in is complete. All right, let's get started. First, open your PyCharm IDE and create a new Python file. Name the file guest check-in system, so it is easy to understand what the program does. All right, at the top of the file, we'll add a comment explaining that this program will help to manage the check-in process for guests. Let's begin by displaying a friendly welcome message to the user. We will use the print function to show a message like, "Welcome to the guest check-in system." All right, let's get started with step 1, where we will ask the user to input the maximum number of guests allowed for check-in. For this, we use the input function to take the user's response and save it in the max underscore guest underscore input variable. In step 2, where we will validate the input as a number. Since the number of guests must be a whole number, we use isDigit method to ensure the input is numeric. If it is valid, we will convert it into an integer using the int function and save it in a variable, and let's call max underscore guess. If the input is invalid, we'll show a message like invalid input. Please restart and enter a valid number. And stop the program using the exit function. Then step 3, where we initialize a variable called guest underscore count and set it to 0. This will help us to keep track of how many guests have successfully checked in. Then in step 4, we'll start the check-in process. For this, we'll use a while loop that continues running as long as guest underscore count is less than the max underscore guest. Inside the loop, we will process each guest's check-in details. For each guest, we first display the current guest number by showing a message like guest 1 or guest 2 using the print function. Then we ask the user to enter the guest name and save it in a variable called guest underscore name. Next, we ask for guest age. To ensure the age is valid, we use the isDigit function. If it is valid, we then convert it to an integer and save it in a variable called guest underscore age. If the input is invalid, we display a message like invalid age, try again, and skip the rest of the loop to let the user try again for the same guest. After the age, we ask whether the guest has a reservation. The input is stripped for extra spaces and converted to lowercase. Based on this reservation status, we handle the check-in process. If the reservation input is yes, we display a message like guest name is successfully checked in, where the guest name is dynamically included in the message. Then we increment the guest underscore count variable by 1 to indicate that one more guest has been checked in. If the reservation input is no, we check the guest age. If the guest is 18 years or older, we display a message like guest name is allowed to check in without a reservation. And again, increment the guest underscore count variable. However, if the guest is under 18, we display a message like, sorry, guest name is under 18 and cannot check in without a reservation, and do not increase the count. If the reservation input is anything other than yes or no, we show a message like invalid input for reservation. Try again. And of course, skip to the next iteration. This process repeats for each guest until the guest underscore count reaches the max underscore count underscore guest, sorry. Once all guests have been processed, the loop ends and we display a message like check-in complete, maximum guests reached. Finally, let's test this program by running it. The program starts and welcomes the user-friendly message. Then it asks the user to enter the maximum number of guests allowed. Let's type, for example, 2. And now the program starts with the first guest. It displays guest 1 and asks for the guest name. Let's type, for example, John. Next, the program asks for John's age, and let's type 25. Then the program asks if John has a reservation. Let's type yes. Since John has a reservation, the program confirms the check-in by displaying message John is successfully checked in. Next, the program moves to the second guest, displaying guest 2 and asking for the name. Let's type Emily. For Emily's age, type 17, and when asked about the reservation, type no. Since Emily is under 18 and has no reservation, it displays sorry, Emily is under 18 and cannot check in without a reservation. Emily is not checked in and the program allows us to try again. So the program prompts again for guest 2 and this time we type Emma. Age 20 and reservation to no. Since Emma is 18 or older and doesn't need a reservation, the program confirms that, and that is Emma is allowed to check in without a reservation. Once the maximum number of guests, which is 2, is reached, it displays check-in complete, maximum guests reached, confirming the process was successful. Now it's your turn to try out the guest check-in system that we just created. Run the program and enter different values for guest details to see how the check-in process works in different scenarios, and I'll see you in the next lecture.